is given by that is the output response of the system, which is computed using the convolution integral formula. Y of t is given by y of t is equal to integral minus infinity to plus infinity x of tau into h of t minus tau dt. Yes, okay, fine. Now, in our problem, we have considered x of t is equal to u of t. And what is my h of t? That is also u of t. Okay, fine. Now, as per the formula, I should find x of tau. So, how to write x of tau from x of t? Very simple. Simply replace t by tau. And before that, what is my unit step function? U of t is equal to, in general, it is 1 for t greater than or equal to 0 and 0 for t less than 0. That is my unit step function. Okay, now, so in our case, x of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. But I want x of tau. So what I will do? Replace t by tau. X of tau is equal to 1 for tau greater than or equal to 0 and 0 for tau less than 0. Fine. Okay. In similar fashion, h of t minus tau has to be determined. Okay. Now x of tau is over. Now we want to find h of t minus tau. Okay. First, write what is h of t? It is unit step function. So 1 for t greater than or equal to 0 and 0 for t less than 0. Okay. Now we want to find h of t minus tau. Yes. Students, is it understandable? Hope it is clear. So h of t minus tau is equal to 1 for t minus tau greater than or equal to 0 and 0 for t minus tau less than 0. Okay. Now, we should write this function with respect to tau because our convolution integral formula is with respect to tau. So, normally what we will do, h of t minus tau is equal to 1 for, normally people used to write like this. Say for example, t greater than or equal to tau and 0 for t less than tau. Okay, but if you write like this is wrong. Okay, why it is wrong? Reason is that the function is with respect to tau, so you have to write the h of t minus tau with respect to tau, but now we have written with respect to t, so this is wrong. So actually we have to write h of t minus tau is equal to 1 for, okay, tau less than or equal to t and 0 for tau greater than t. Okay, now we are writing this function with respect to tau. So x of tau is a function with respect to tau and h of t minus tau is a function with respect to tau. You should not write like this. Okay, is it clear? Fine. Okay. So now, as per the convolution integral formula, we have written x of tau, h of t minus tau. Okay. Now, next. And now what is this t actually? Here the function is with respect to tau and now we are writing this t as a constant. It is a function with respect to tau and here t is a constant. It may be 0 or it may be less than 0 or it may be greater than 0. Okay, fine. So, after writing this x of tau and h of t minus tau, please check it whether you have written correctly or not. That is more important. Okay, once if it is correct, then we can go for the actual mathematical computation. It is very simple. Okay, so now we are going to represent this signal diagrammatically. Okay, so that you can clearly understand what is x of tau, what is h of t minus tau. Okay, so to start with, let me draw an y-axis like this and let it be x-axis. Okay. Now, let me complete x of tau first. Okay, so tau, and this is my x of tau. This is my 0. Okay, now What is my x of tau? It is 1 for tau greater than or equal to 0 and 0 for tau less than 0. So from minus infinity to 0 it is 0. From 0 it is 1. Okay, so this is my x of tau. Hope you can understand this, because already we have represented signal in graphical form during the beginning of the session. So this is how you need to plot x of tau. So for the reference I will write taking x of tau is equal to 1 for tau greater than or equal to 0 and 0 for tau less than 0. Next, very important thing, now I want to plot this h of t minus tau. Okay. Now what is h of t minus tau actually? It is h of t minus tau is equal to 1 for tau less than or equal to t and 0 for tau greater than t. Okay. Now comes the very important thing. Now h of t minus tau is equal to 1. Okay. For tau less than or equal to t. So once again I will repeat, h of t minus tau is equal to 1 for tau less than or equal to t and 0 for tau greater than t. That is, tau less than or equal to t represent the signal is coming from minus infinity end. Okay. So from minus infinity it is 1. Okay. But up to t, so this 1 is coming from minus infinity up to t. So this t, it can be 0 or it can be greater than 0. But let us assume, okay, t is less than 0. Okay, t is less than 0. So in this case, t is less than 0. Okay. See, we are assuming like this for the sake of simplicity, and moreover we should assume in such a way that this signal is not overlapping with this x of tau. That is, we are assuming t in such a way that h of t minus tau is not overlapping with x of tau. This is for sake of simplicity. First we are assuming like that. Okay. So now here there is no overlap. Okay. Now you can assume a value of t such that h of t minus tau can be overlapped with this x of tau. So what we are doing, initially we are assuming a t such that it is not overlap, and now we are going to assume a t such that it overlap with this x of tau. That is, h of t minus tau should overlap with this x of tau. Okay. Now tell me, for what value of t this h of t minus tau overlap with this x of tau. That is, for what t h of t minus tau overlaps with x of tau. This is my question. Can you tell me? Okay, yes, very good. So that is, for t greater than or equal to 0, your h of t minus tau overlaps with x of tau. Okay, fine. Now, so when we assume t greater than or equal to 0, your h of t minus tau overlap with x of tau. So in this case, okay, my signal h of t minus tau will come from minus infinity, okay, and it will come up to this t. Okay, so here we are assuming t greater than or equal to 0. Initial case t less than 0, so no overlap. Here t is greater than or equal to 0, so it is overlapping with x of tau. Now if you consider the overlapping region, so now overlapping region, if you consider this overlapping region, okay, please tell me, this is my t. So I think, okay, if this is my t, my h of t minus tau and x of tau get overlap for a duration of t. So this is my final overlapping region. Okay, this is 1. Okay, this is 1. Okay. So the amplitude is 1 here, it is 1, 1. So my h of t minus tau, x of tau overlap within the region 0 to t. Okay, Now let us proceed as per the convolution integral formula. Y of t is equal to, in general, it is minus infinity plus infinity, integral minus infinity plus infinity, x of tau, h of t minus tau d tau. Okay. So now in our case, y of t is equal to integral. What is the overlapping region? 0 to t. So 0 to t. Within this region, what is the value of x of tau? Within this region, the value of x of tau is 1. Okay, 1 into, what is the value of h of t minus tau within this region? That is also 1. So 1 into dt. So integrate 0 to t dt is equal to, so t upper limit is t, lower limit is 0. So the answer is t. Okay. But what is the condition for t greater than or equal to 0? So my final answer y of t is equal to t for t greater than 0. So here the output response of a system with x of t is equal to u of t and h of t is equal to u of t is y of t is equal to t for t greater than or equal to 0. So this is my final output response. Okay. So now once again I will show you a short summary. Okay. We are finding the output response of the system where the input response is u of t, where the impulse response is h of t, x of t is equal to u of t, h of t is equal to u of t. We are supposed to find what is my y of t. Okay, so we are finding y of t, the output response of the system, using the convolution integral formula. Y of t is equal to integral minus plus x of tau, h of t minus tau d tau. Initially what we are doing, we are writing the x of t function and then convert that function into x of tau. Then we are writing h of t, write the function h of t minus tau, okay, and then write the h of t minus tau with respect to tau. Please don't write h of t minus tau with respect to t, okay. So x of tau, h of t minus tau. Now please plot the signal x of tau and h of t minus tau. To start with, first complete x of tau. Okay, so it is a unit step function. Next, h of t minus tau. When you draw the h of t minus 2 signal, h of t minus tau signal, what you should do is, initially you assume t such that it is not overlapping with x of tau. So t less than 0, it is not overlap, so assume like this. Okay. Now, next step, you consider t such that it gets overlapped with this x of tau. So under what condition this x of tau overlap with this h of t minus tau? Definitely when t greater than or equal to 0, your h of t minus tau will overlap with this x of tau. So this is my h of t minus tau for t greater than or equal to 0. Now if I compare this x of tau and h of t minus tau, my overlapping region is 0 to t. So from between 0 to t, h of t minus tau value is 1. Okay. So this is my overlapping region. Okay. So now you can say that this is my h of t minus tau. Okay, overlapping with x of tau. Okay. So as per the convolution integral formula, the overlapping region is 0 to t. X of tau value is 1, h of t minus tau value is 1. So integrate this one with respect to t. So naturally we will get t for t greater than or equal to 0. So this is my final output response of the system. Okay. Now, how will you check whether this convolution integral problem is right? Okay. You have a very simple method. It is a very easy method also. So as we are familiar with the Laplace transform, okay, what we can do is, okay, let us analyze the same problem. Okay, let us analyze the same problem using Laplace transform. Okay, so my y of t output response is x of t star h of t. And what is the convolution property of Laplace transform? Yes. So by taking Laplace transform on both sides, we get y of s is equal to x of s into h of s. Okay, now for this x of t, what is my x of s? What is the Laplace transform of u of t? That is unit step function, it is 1 by s. And what is the Laplace transform of h of t? That is h of s is equal to h of t is also u of t. Laplace transform is 1 by s. Okay. So now my y of s is equal to x of s into h of s. So I will get 1 by s into 1 by s, that is 1 by s squared. So now what is my y of t? Laplace transform inverse of 1 by s squared. Okay. Now what is the Laplace transform inverse of 1 by s squared? Again, coming back to Laplace transform. So this is my x of t and this is my x of s. Okay. If for impulse function, okay, the Laplace transform is 1. Okay. And what is the Laplace transform of u of t? It is 1 by s. And what is the Laplace transform of t power n u of t? Yes, as per the property it is, okay, n factorial divided by s power n plus 1. So if it is t into u of t, okay, it is 1 factorial by s power 2. So that is equal to 1 by s squared. So by applying this, okay, by applying this, I will get y of t is equal to t into u of t. So using convolution integral method, okay, using convolution integral method, I got y of t is equal to t for t greater than or equal to 0, and Laplace transform y of t is equal to t into u of t. Both are same because u of t will exist for, what is u of t? It exists for 1 for t greater than or equal to 0 and 0 for t less than 0. So you can write this as y of t is equal to, okay, t for t greater than or equal to 0. Okay. So this is how you can find the output response of the system using convolution integral formula. Okay. So once again, you please go through the steps from 1 to n, so that it is clear that the output response of the system using convolution integral formula is derived in an easier way. Okay, please go through it.